let's continue our journey. We have passed through the magnetic field, through the atmosphere, and we finally landed on the surface of the Earth, right? This is where we live. This is part of the Earth that we are most familiar with. And the reason we're able to live here is because Earth's surface lies within what we call the habitable zone, right? That very thin zone within our solar system that is close enough to the sun to be not too hot, not too cold, right? The perfect temperature for life, the perfect temperature for us, where liquid water can exist. That's really important. Any closer, the water would vaporize. Any farther away, the water would turn to ice. So there's this habitable zone where the temperature is just right, that liquid water can exist. And that's why we are able to live here. So Earth's surface is in the habitable zone, the Goldilocks zone within our solar system. And dry land, the part that we live on, only covers about 1/3 of Earth's surface, or 30%. Right? The rest of it, the other 70%, is the ocean, lakes, rivers, water, right? So much of what we know and much of what we're going to talk about in this class is all from the land, right? But I just want you to keep in mind that we're actually talking about a very small percentage of Earth's surface. Most of Earth is made up of the ocean. And I teach a marine geology class too, if you're interested in that and want to keep going. Okay. So we talk about the land and the ocean with different words, different vocabulary. When we talk about the elevation of the land, we use the word topography. Right? So topography just means the variations in elevation of the land surface. Think plains, mountains, valleys. Right? We can talk about the same thing in the ocean, we just use a different term for it. We call that bathymetry, right? So that's the elevation of the ocean floor. Again, there's abyssal plains, there's mid-ocean ridges, there's deep ocean trenches. We just use a different term, bathymetry versus topography. Right, so I want you to just take a second, look at the map on your screen, see the dark brown mountains, see the dark green coastal plains, see the dark blue abyssal plains, see the light blue ridges, the mountains and the oceans, and think to yourself, why do they look the way they do, right? There seems to be some patterns. What might that tell you about the way that Earth is formed? Keep that in your head. We're going to come back to that. So most of Earth's surface lies at moderate elevations, right? Plains. A small portion lies at really high elevations, the mountains, and really, really deep elevations, the trenches. But most of Earth lives at the elevation, or lies at the elevation that we live, right, along the plains. Now, Earth's surface is made up of lots of different elements, but of the 92 naturally occurring elements, almost all, 91% of Earth's mass consists of just 4, which makes it really easy on us. Right? Thank you, Earth, for making this science easy for us. We've got 4 elements that make up 91% of Earth's mass. We've got iron, oxygen, silicon, and magnesium. Great. So extrapolate that. I want you to think to yourself, think back to what you've learned previously. Of these 4 elements, iron is the heaviest, right? It's the densest. Where within Earth do you expect to find the most iron? Right? Think back to when we talked about how when Earth was first formed 4.6 billion years ago, it was still molten, right? Still a liquid. So material was able to easily move within Earth, flow within Earth, and iron, because it was really dense, really heavy, it sunk down to the center of the Earth. Gravity pulled it down to the center of the Earth. Right? So even today, now that Earth has cooled and solidified, hardened into a solid, we still find most of the iron inside of Earth.